Hello everyone. Chapter 2, part 3. Write chemical formulas from chemical names. So here, right? First, write the chemical, the symbol of the metal and the non-metal, and its charge. For example, magnesium is in the group 2A, so 2 plus, and nitrogen is in the group 5A, so usually 3 minus. Now, let's calculate here. So, the charge of the non-metal will be the subscript of the non-metal. So, magnesium charge is 2 plus, so that it means you will have 2 nitrogen. Are you seeing here? And the charge for nitrogen is a 3 minus, that means we will have 3 magnesium. Are you seeing here? Right. Okay, so you know the magnesium is a 2 plus, nitrogen is a 3 minus. We know that we are doing this because the net charge is 0, right? So let's check here. 3 times plus 2 is a plus 6. And 2 times minus 3 is a minus 6. That's equal to plus 6 minus 6, 0, right? Okay, now let's do the same for lithium phosphide. So lithium is in the group 1A periodic table, 1A, and phosphorus is in the group 5A. That means what? Lithium will be a 1 plus charge, and phosphorus is a 3 minus. Okay, so you know that's the same thing, right? Here we know the net charge should be 0. So let's do like this. The charge for the non-metal will be the subscript for the non-metal. So it will be 1 phosphorus. And then the charge for the non-metal will be the subscript for the metal. So we have 3 lithium. So it's going to be like this. Lithium, 3, phosphorus, 1. Lithium phosphide. If you're going to check the charge, make sure it's correct. Let's make the calculations here. So each lithium is a 1 plus, and each phosphide is a 3 minus, right? Let's check here if the net charge here will be 0. 3 times 1, 3, and 1 times minus 3. Okay, right? 3 minus 3, 0. Right? Okay. Now, the next topic here is naming transition metal ionic compounds. So this one here, magnesium nitride and lithium phosphide, they are not transition. The lithium and magnesium, they are not transition metals. And it means the charge will not change for these no metals. Sorry, for these metals. But we have some metals that the charge change. They are called transition metals. So if you have ionic compound with transition metals, will be a transition metal ionic compounds. These metals, they have a metal that they can form more than one type of cation. For example, here, iron can be iron 2 plus or iron 3 plus. Gold can be gold 1 plus or gold 3 plus, right? So using the Roman numerals here, they indicate that this number here indicates the charge of the non-metal. So those are gonna be changed here because the transition metals, you need to add the charge in Roman numerals. For example, iron oxide. Let's name this compound here. Oxygen is usually 2 minus, is in group 6A. You know the total should be what? 0 here, right? So what will be the charge for iron? Iron, in that case, will be what here? Will be a 2 plus, right? To neutralize it here. Plus 2 minus will be 0. So for that case here, you don't need to do the crossover because here the metal and no metal, they have the same charge. When they have the same charge, you don't need to cross like this, right? Because here, if you calculate here, if they have the same charge in the same numbers of each one, like here, 1, 1, 2, 2, so you don't need to do anything. You don't need to cross the numbers here. So plus 2 minus 2 will be 0. What's the name for this compound here? So iron, right? Iron. What's the charge here? 2. So we need to write the 2 between parentheses in Roman numerals. Numerals. And oxide. Okay. So the next one, let's see if you have, okay, this one has iron and oxygen as well. But what will be changed here is the quantity, right? Okay. All right. So oxygen is usually what? 2 minus, right? So let's discover here what are going to be the charge for the iron. Let's call X. And let's make the math here. 2 times X, 2X, minus 2 times 3, minus 6, right? X here is equal to 6 divided by 2. So you know that your X will be equal to 3. That means your iron here is a plus 3. You also can calculate the charge just by doing the crossover, right? For example, here, the charge of the non-metal indicates the charge of the metal is equal to the subscript of the non-metal, and the charge for the non-metal is the subscript of the metal here. The total is 0. Okay, what's the name for this compound? What's the charge for the iron here? Is that 3, right? So what's going to be the name here? The iron. The charge is 3. So iron 3 oxide. All right? Okay. Right. Now let's go to ternary ionic compounds. Is when you have ionic compound with polyatomic ions. Polyatomic ions are ions with more than one atom. For example, here, nitrate, you have 1 nitrogen and 3 oxygens. Sulfate is a SO4, 2 minus. Ammonium is a NH plus, NH4 plus. So there is a video that I show how to, there is a video about polyatomic ions that I show the polyatomic ions that you need to memorize. right? So, like this, you need to learn that nitrate is a NO3 minus, and when the nitrate has one oxygen less, changes from nitrate to nitrite. 8 changes to ide. The same thing here. Sulfate has 4 oxygens. Here, nitrate has 4 oxygens, right? And sulfate has 4 oxygens here. And when you lose with 1 oxygen less, changing from 8 to 8. So gonna be sulfite, SO3. 2 minus will be a sulfite, right? Okay, so write formulas for compounds with containing a polyatomic ion. When writing formulas for ionic compounds containing polyatomic ions, we use the same rules of charge balance as those for simple ionic compounds. The difference here that you are going to count the charge of the polyatomic ion as a 1 terms here. Like magnesium is a 2 plus. Each nitrate is a -1. So how many nitrates do you need? So if you have 2 magnesium nitrate, if you have 2 magnesium or 1 magnesium, and each 1 magnesium is 2 plus, that means you needed 2 minus here. So if each nitrite is 1 minus, that means you need 2 nitrite. The parentheses here are placed around the polyatomic ion here, like magnesium nitrate, and this number here, the subscript is placed just outside the parentheses, indicating that you have 2 nitrogens, okay? So when, blurry, okay, go back. Naming compounds with polyatomic ions. When naming ionic compounds containing polyatomic ions, first write the positive ion, so usually the metal, then write the name of the polyatomic ion, so you know that sulfate is a SO4, right? Right, and then like sodium sulfate, iron 3-phosphate, and aluminum carbonate. All right, what the next one? Here. So let me check here. So have here some practice problem, right? Select the correct formula for each compound. So nitrate is a -1, right? And aluminum is in the group 3 plus 3A, so that means the aluminum is a +3, right? 3 plus. What we're gonna do here, that means you need 3 nitrates, so the answer is aluminum nitrate. To make aluminum 3 plus, you're gonna indicate that you need 3 nitrates. And nitrate is a 1 minus, so just need 1 aluminum here. And letter B, copper 2 nitrate, right? So you know copper is a 2 plus because it says here, right? The Roman numerals is right here. It's saying that you need that it's that 2 plus. So copper 2 plus. Each nitrate is what? Is a 1 minus, right? So that means you needed 2 nitrates and 1 copper. So let's see the number 2 here. So each nitrate is a -1 or 1 minus, right? So we have 2 minus here. 2 times -1, 2 minus. So copper, gonna be a 2 plus. The answer is number 2 here. Next is about molecular covalent compounds. So molecular compounds are composed of molecules and almost always contain only nonmetals or metalloids. These compounds do not involve ions or charge. And the 7 elements occur naturally as molecules containing 2 atoms. So hydrogen, the most common here, these seven elements here, they occur naturally as molecule contains 2 atoms. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So what's going to be different from any ionic compounds? So covalent compounds between nonmetals or metalloids, right? Okay. So naming covalent compounds will be like simpler than performing for ionic compounds, mainly because covalent compounds you do not have ions, right? What thing to pay attention for covalent compounds, the chemical symbols, and the number of each type of atom. So first, what we're gonna do here, name ion compound. So the first one will not change as it is. So like nitrogen, the first one element will not change, be as it is. The second one, we change the ending to "ide." Here. The first nonmetal is named by its element name, and the second name is named by using the first syllable and its name followed by "ide." When the subscript indicates 2 or more atoms, you're gonna add the prefix of indicate how many we have. So the first one, nitrogen, okay, nitrogen, right? And then oxide. How many oxides do we how many oxygens do we have here? 2, right? So nitrogen dioxide, right? Next one here. How many nitrogens do you have? 2 nitrogens and 3 oxygens. So dinitrogen trioxide, correct? Trioxide here. So you'll be saying the name of the elements, right? And how many do you have? Like if the first element is just 1, you don't need to say mono, right? But if the second element has only 1, then you need to say mono. Like for example, what's the name for this one here? We have only 1 carbon and 2 oxygen, right? Gonna be what here? Carbon, carbon dioxide, correct? Yeah. And about this one here, carbon monoxide. So you want to say mono for the second element. Like for example, we do not say carbon monoxide, right? You just say carbon monoxide. And I'll let these ones here for you guys to practice. 2-di-5-penta, right? So here should be diphosphorus pentaoxide. Now for acids, write the chemical names in chemical formula for acids. If the anion in the acid ends in "ide", change the end to "ic" acid and add the prefix hydro. For example, HCl. So the anion Cl finishes in "ide", so gonna be "ic" here. So HCl, hydrochloric acid. Bromide here, like the bromine, it ends in "ide", so change "ide" to "ic" acid. So hydrobromic acid, correct? Same thing for iodine. Here, the iodide here, we change it to hydroiodic acid. So if the anion and acid ends in "ide", change the end to "ic" acid and the prefix to hydro. So hydrochloric acid, you have it here. And if the anion and the acid ends in "ate", change the end to "ic" acid. So, for example here, like chlorate. The chlorate here, this polyatomic ion here is a chlorate. The anion ends in "ate", change the end to "ic" acid. So here, chloric acid. This HClO4 is a perchloric, so actually it's a perchlorate. So change the "ate" to "ic" acid. Like here is when you have polyatomic ions in the acid. Change the "ate" to "ic" acid. That is the same rule here for the finishing in "ide". So, if the anion in the acid ends in "ide", that means if it has one less oxygen, right? Change the ending to "ose" acid, like hypochlorous acid and chlorous acid, like here. The SO4, you know this sulfate, right? The sulfate here, we change the H to "ic" acid, so it will be sulfuric acid. So it will be a sulfuric acid, right? And here, SO4 is a 8, but SO3 is a ite, so change the ite to sulfurous acid. Sulfurous acid. This is C, and this is D. The last topic for naming ionic compounds. Okay. Organic compound. Last topic here is naming organic compounds. Alkanes first, and then alcohols. Organic chemistry is the study of carbon, so all organic compounds will have carbon. And we name by counting how many hydrogens we have. And if you have, like here, only carbon and hydrogen, you count hydrocarbons. And the hydrocarbons will be like finished in "ane", "ine", or "ine", but let's focus just on finishing in "ane". The one that finishes in ane because they have single bonds. So let's focus on the single bonds here. Okay, so how many carbons we have in the first one? One carbon, so one carbon is meth. So methane here, methane. So this all hydrocarbons with single bonds will finish in and will end the word will end here in ane. So when you have two carbons, the syllable will be the first syllable be F. So ethane, it's ethane here. Two carbons, ethane. If you have three carbons, it will be prop. So be propane here, propane. If you have alcohols will be instead of all hydrogens here, bond to carbon will be one of it will be changed to OH. So the alcohols they'll have OH here. Are you seeing here? Among the same compound, right? Just change the hydrogen to OH. The difference is if you have OH here, we'll finish with all. Okay? So for example, one carbon, methane, because this is OH is an alcohol, so ends in all. So methanol. Two carbons, ethanol. Three carbons, propanol. So this is the ending here of chapter 2.